The reactant has two functional groups, alkyl bromide, alkyl chloride. It is treated with aniline, also known as benzenamine. So it is a nucleophile. So nucleophilic substitution takes place. It is simply SN2 reaction. It is a nucleophilic substitution. If you observe the product, again another possibility is also there, intramolecular SN2. Intramolecular SN2, also known as NGP. So the final product is, so ring formation 1, 2, 3, 4, 5, 6, benzene, nitrogen and 6-membered ring. 1, 2, 3, 4, 5, 6. Second carbon methyl, sixth carbon methyl. So it is a final product and it is a tertiary amine. It is a tertiary amine. Tertiary amine treated with nitration mixture HNO3 and H2SO4. So here from this mixture we get electrophile NO2 plus. Since it is a tertiary amine, even though it is OP directing group, but because of the tertiary amine, it gives majorly meta directing product. It gives majorly meta directing group, because in acidic medium this N lone pair take the proton and converted into corresponding anilinium ion type molecule, and it is meta directive because of the positive charge. That's why it gives majorly meta nitro product. Now it is treated with Fe plus HCl. We can also use zinc HCl. We can also use SnHCl, and we can also use H2PD in ethanol solvent. Of course, among these, Fe plus HCl is the best reagent. So it reduces corresponding nitro group. It reduces corresponding nitro group to corresponding NH2. NO2 group reduce it to NH2. NO2 group reduce it to NH2. Aniline when treated with bromine water or Br2CS2, so it undergo electrophilic aromatic substitution. So we get corresponding white PPT 2, 4, 6 tribromoaniline. It is a white PPT 2, 4, 6 tribromoaniline in the presence of bromine water or in the presence of Br2 in non-polar solvent CS2. Now the product is treated with NaNO2 H2SO4. From this we get NO plus electrophile. So whenever NH2 react with NO plus, this reaction is known as diazotization. This reaction is known as diazotization, and the corresponding product is NH2 will be converted to N2 plus corresponding tribromo. This diazonim salt treated with reducing agent H3PO2 or ethanol. So this diazonin compound undergo reduction. So in place of N2 plus, simply we have to take hydrogen, and it is a reduction. H3PO2 undergo oxidation, or if I use alcohol undergo oxidation, gives corresponding aldehyde. So it is an example of reduction of diazonim salt. alpha amino acid. It is also known as alanine. Alpha amino acid treated with HNO2. So here in place of NH2, we will get N2 plus. N2 plus. Now within the molecule, acid group ionizes. So COO minus attack, leaving group will leave. Now the corresponding nucleophile water attack. So finally we get corresponding alpha hydroxy acid. Alpha hydroxy carboxylic acid. So this overall reaction is NGP mechanism. So first మనకి NH2 ప్లేస్లో N2 ప్లస్ ఫామ్ అవుద్ది. తర్వాత N2 ప్లస్ లీవ్ అవ్వకముందే ఇంట్రామాలిక్యులర్ SN2 ఇన్వర్షన్ జరుగుతుంది. 3 మెంబర్డ్ లాక్టోన్ ఫామ్ అవుద్ది. 3 మెంబర్డ్ లాక్టోన్ అన్స్టేబుల్. సో మళ్ళీ న్యూక్లియోఫైల్ అటాక్ అవుద్ది, రింగ్ ఓపెన్ అవుద్ది, అగైన్ ఇన్వర్షన్. సో 2 టైమ్స్ ఇన్వర్షన్ జరిగి ఫైనల్గా మనకి రిటెన్షన్ ఫామ్ అవుద్ది. సో దిస్ ఓవరాల్ మెకానిజం ఈజ్ నోన్ యాజ్ neighboring group participation. Now the alpha hydroxy acid, it is a alpha hydroxy acid. If I ignore stereochemistry, so when alpha hydroxy acid is heated, we have to take 2 moles grantedly. We have to take 2 moles grantedly. Alpha hydroxy acid. So here intermolecular lactone formation, ester formation, and the corresponding product is like this. So when alpha hydroxy acid is heated, we have to take 2 moles grantedly, and we have to write corresponding lactone, dilactone, also called dilactide. Now it is treated with strong reducing agent lithium aluminum hydride. Suppose if I take carboxylic ester like this, when it is treated with LiAlH4, this carboxylic ester undergo reduction. So it will be reduced completely, RCH2O minus, and the leaving group is RO minus. Now after acidification, the corresponding product is RCH2OH, ROH. So similarly here we can break the ester bond. So the corresponding product is leaving group part OH, acid part CH2OH, and here acid part CH2OH and leaving group OH and methyl. So this is a final compound. So these are the final compounds. The reactant has primary amine, and the reagent is Hinsberg reagent. Hinsberg reagent has leaving group, and here primary amine is nucleophile. And we are adding only one equivalent of Hinsberg reagent. So here less sterically hindered, more sterically hindered. So less sterically hindered nucleophile attack, and corresponding primary sulfonamide will form NHSO2 pH. So this part is primary sulfonamide. Now to this compound we are adding acetyl chloride. CH3COCl, acetyl chloride. Acetyl chloride has leaving group, and here primary amine and sulfonamide both are nucleophiles, but it is participating in the resonance. Therefore, it is a weak nucleophile. It is a strong nucleophile. Therefore, N lone pair attack, leaving group will leave, and the corresponding product will form. So this reaction is acylation reaction. Acylation reaction. And to this product, we are adding aqueous NaOH. We know that amide is neutral, but primary sulfonamide is acidic, and which is more acidic than water. Primary sulfonamide more acidic than water. Therefore, this OH minus remove the acidic proton and corresponding salt will form. Corresponding salt will form. And the salt is, because of the salt formation, this compound is water soluble. This compound is water soluble. The first reaction is Hinsberg reaction. Second one is N-acylation. Third one is acid-base reaction. And here we should remember amide. Amide functional group insoluble. Amide functional group insoluble in aqueous HCl, aqueous NaOH, aqueous sodium bicarbonate. But soluble, amide is soluble in hot aqueous NaOH. It is soluble in hot aqueous NaOH, insoluble in these reagents. The reactant is phthalic anhydride. The reactant is phthalic anhydride. When phthalic anhydride treated with ammonia, so initially nucleophilic substitution takes place. Initially nucleophilic substitution takes place. But because of heating, again here nucleophile intramolecular reaction takes place, and finally we get corresponding phthalimide. Finally we get corresponding phthalimide. This compound is known as phthalimide, and it is more acidic than water. Phthalimide is more acidic than water. Therefore, when I add KOH, OH minus remove the proton and form corresponding salt. Form corresponding salt. And this can act as strong nucleophile because of negative charge. And since it is a more acidic than water, it always acts as a strong nucleophile. When it is treated with alkyl chloride, SN2 reaction takes place. Therefore, N lone pair attack, negative charge attack, leaving group will leave. Therefore, corresponding product is above the plane nitrogen, double bond O, double bond O. So it is a N-alkyl phthalimide. N-alkyl phthalimide. Now it is treated with NaOH, H2O, heat. So here this functional group undergo hydrolysis, and finally we get corresponding COOH after acidification, and above the plane NH2. So this entire reaction This entire reaction is known as Gabriel Thallamide reaction, and this method is suitable to prepare primary aliphatic amine. Primary aliphatic amine, it is a suitable method. Sometimes if hydrolysis is difficult, we use hydrazine. If hydrolysis is difficult, we use hydrazine. So here N lone pair attack, leaving group will leave. N lone pair attack, leaving group will leave. Therefore, the corresponding product is C double bond O, C double bond O, NH2, NH2. So N lone pair attack, N lone pair attack. And the corresponding leaving group is, this is a leaving group. So whenever hydrolysis is difficult, we use hydrazine, and finally we get corresponding aromatic compound and our required aliphatic primary amine. So the reactant has alkyl halide functional group, bridge carbon Br, secondary carbon chlorine. It is treated with ambident nucleophile KCN in polar aprotic solvent. When alkyl chloride treated with KCN, it gives two products, cyanide plus isocyanide, and cyanide is major. When it is treated with AgCN, it forms RCN plus RNC, and isocyanide is major product. When you are using Ag plus, it undergo SN1 mechanism. When you are using KCN, it undergo SN2 mechanism. Therefore here the corresponding major product I am considering here. So major product is cyanide, SN2 reaction. Now it is treated with dibal. So we know the basic reaction. When cyanide treated with the dibal, cyanide undergo reduction, and finally it gives corresponding aldehyde after hydrolysis. So hydrolysis granted. Therefore the corresponding product is after hydrolysis. After hydrolysis, the corresponding product is Br remains unaffected and corresponding aldehyde. Now it is treated with secondary amine followed by H2PD. When you are adding secondary amine, nucleophilic addition takes place, because we know that bridge carbon do not participate, and finally we get corresponding product like this. Now this product undergo dehydration immediately to get corresponding conjugate product. At the same time, it is also treated with H2PD. So this alkene functional group undergo reduction. And finally we get corresponding product like this. So this is a enamine functional group. When enamine treated with H2PD, alkene part undergo reduction. So this is our final product. The reactant is known as cinnamic acid. When cinnamic acid treated with SOCl2 in place of OH, we get corresponding chlorine. When it is treated with ammonia, ammonia is a nucleophile, and chlorine is leaving group. It is a nucleophile and leaving group. So SN2 reaction takes place, and finally it gives corresponding carboxylic amide. Carboxylic amide. When carboxylic amide and alkene treated with H2PD, we know that H2PD do not reduce acid, ester, amide and epoxide. So these four functional groups cannot be reduced by H2PD. So only alkene part undergo reduction, amide part do not undergo reduction. Therefore the corresponding product is, so this is our corresponding product. So it is our amide. The reactant has cyanide functional group. Cyanide functional group treated with NaOH H2O heat. So when cyanide treated with NaOH H2O without heat, so here OH minus attack, pi bond shifted, it gives corresponding product like this. Now after tautomerization, it converts into amide. Suppose heat is not given. And the same cyanide, when it is treated with NaOH H2O in the presence of heat, cyanide undergo complete hydrolysis and we get corresponding carboxylic acid and ammonia. We get corresponding carboxylic acid and ammonia. Therefore here heat is given, the cyanide part undergo hydrolysis and we get corresponding carboxylic acid and inorganic compound ammonia. When it is treated with soda lime, NaOH CaO combination is known as soda lime. So when we are using soda lime with carboxylic acid, so decarboxylation takes place. Decarboxylation takes place. So we have to remove the CO2 and write down the carbon ion C minus. No other possibility, acidification granted. And we should also remember rate of decarboxylation with soda lime directly proportional to stability of C minus. Directly proportional to stability of C minus. So here the product is alkane. When alkane treated with Lewis acid and HCl, this reaction is isomerization. So butane undergo isomerization, we get corresponding isobutane. So we will get corresponding isomeric compounds. What are the possible isomers we get? Here of course only one isomer is possible, that is isobutane. The first reaction is complete hydrolysis. Second reaction soda lime decarboxylation. And third reaction isomerization. The reactant has two functional groups. One is tertiary alcohol. Another one is primary amide. It is treated with NaOBr. So it is also equal to Br2 plus OH minus, also equal to Br2 plus CO3 minus 2, and also equal to Br minus plus BrO3 minus. So we know that it is a Hofmann bromamide reaction. Hofmann bromamide reaction. In Hofmann bromide reaction, the corresponding carboxylic amide initially converts into isocyanate. So this functional group is known as isocyanate. Now it undergo hydrolysis and finally we get corresponding amine type molecule. So it is a Hofmann bromamide reaction. But we know that if the same carbon has OH and NH2, we have to remove ammonia and finally we get corresponding thermodynamically stable ketone. By losing ammonia, we get thermodynamically stable ketone. Now the ketone treated with zinc mercury conc and this reagent is known as Clemmensen reagent. This reagent is known as Clemmensen reagent. So the Clemmensen reagent, it reduces keto group to corresponding alkane. It reduces keto group to corresponding alkane. CO group converted to CH2. It is simply equal to methyl cyclohexane. Methyl cyclohexane, because it is not chiral center right now. Now it is treated with Cl2H nu. It is a alkane Cl2H nu free radical substitution. Therefore we get mixture of products. First product is like this, second product is like this, and third product is like this, and fourth product and fifth product. So this carbon stereo is right now, it is not fixed. We can write above and below. So if I consider stereo, one compound here, one compound here, and here RR configuration because of two chiral centers, RS configuration, SR configuration, SS configuration. Total 4 compounds. Similarly here also two chiral centers because two possibilities are there, both R and S possibilities. So based on that one, we are getting corresponding 4 products. Now here there is no chiral center, but here we can write cis isomer plus trans isomer. Therefore we get 2 compounds. Here 2 compounds, here 4 compounds, here 4 compounds, here 1 compound, here 1 compound. So on monochlorination, we get mixture of products like this. And here these two are enantiomers. These two are enantiomers. In this case also these two are enantiomers and these two are enantiomers. The first reaction is Hoffman bromamide reaction. Second reaction is Clemmensen reduction. Third reaction is free radical substitution. The reactant has three functional group: alcohol, amine and nitro. When it is treated with HNO2, from HNO2 we get NO plus. So NH2 react with NO plus, converts into, NH2 will be converted into N2 plus. Now it loses N2 plus and form corresponding stable C plus. Corresponding stable C plus. So initially NH2 group converted to N2 plus, that is diazotization. It loses N2 gas and finally form stable C plus. Suppose this carbon get positive charge, so lone pair octet is possible. So when this is a case of octet, when octet case is present, migrating aptitude generally H minus, pH minus, R minus. It is a general migrating aptitude in the case of octet. Therefore here pH minus migrate and corresponding product is methyl C plus benzene and nitrobenzene. After migration, it is a final product. Now because of lone pair resonance possible and it loses proton, finally we get corresponding CH3, C double bond O, CH3, benzene and nitrobenzene. So we get our corresponding ketone. Now the ketone treated with bleaching powder CaOCl2. So bleaching powder contains Ca plus 2, Cl minus and OCl minus. OCl minus equal to Cl2 plus OH minus equal to Cl2 plus CO3 minus 2 equal to Cl minus plus ClO3 minus. So when ketone, here methyl ketone is present. When methyl ketone treated with Cl2 plus OH minus, this reaction is known as haloform reaction. This reaction is known as haloform reaction. So here haloform reaction takes place. The CH3 group will be converted into chloroform. The CH3 group converted into chloroform, and the corresponding keto group converted into acidic part. After acidification, grantedly I am taking acidification, so I get corresponding carboxylic acid. So this is our second product because of haloform reaction. Now it is treated with NaOH, CaO, heat. It is what we call soda lime. In the presence of soda lime, the carboxylic acid undergo decarboxylation. Decarboxylation. So after losing CO2, it forms minus corresponding carbon ion, but no other possibility. Therefore, I am taking acidification grantedly. So this is our final product. It is our final product. The first reaction is pinocol type reaction, pinocol pinocolone. Second reaction is haloform. Third reaction is decarboxylation. The reactant has aromatic primary amine treated with NaNO2 H2SO4, and heat is also given. So this reaction is diazotization. Diazotization. Therefore here what happens? NH2 will be converted into N2 plus. It is called diazotization. Since heat is given, it loses N2 gas and form corresponding carbocation. Form corresponding carbocation. Now this carbocation undergo electrophilic aromatic substitution. Since it is electrophile, it is aromatic compound. So electrophilic aromatic substitution. Electrophilic aromatic substitution. Now it is treated with NBS. NBS is N-bromosuccinimide. N-bromosuccinimide. Always it contains some amount of HBr as impure compound. Whenever NBS is used, it undergo free radical substitution mainly at allylic and benzylic carbons. Mainly at allylic and benzylic carbons. So this is a benzylic carbon. Benzylic carbon undergo free radical substitution. Benzylic carbon undergo free radical substitution. So this is our corresponding product, free radical substitution. Now it is treated with SO2Cl2. SO2Cl2. So whenever we use SO2Cl2, it also undergo free radical substitution. So initially it forms stable radical. There is only one possibility, even though the yield is low, but it forms. Because we know that if already halogen is there, second time FRS is not that much favorable. But here no other possibility. That's why it forms radical at the same carbon only. Now it reacts with the Cl, and finally we get corresponding geminal dihalo compound. If the two functional groups connected to same carbon, that is called geminal. Now it is treated with sodium and ether. So we know that when alkyl chloride treated with sodium, it gives RR. Suppose when geminal compound treated with sodium, so initially dimerization takes place like this. Again it undergo intramolecular Wurtz reaction. Cl will leave, radical will form, Cl will leave, radical will form, finally it forms corresponding alkene. Similarly in this case also two halogens are there. So first molecule and second molecule. So first Woods reaction, second Woods reaction. So this is our final compound. The first reaction is diazotization followed by electrophilic aromatic substitution. So it is our first compound. Second reaction is free radical substitution. Free radical substitution, it is our second compound. And with sodium Woods type reaction, it is our final compound. The reactant is acetanilide. So it is a acetanilide, anyl ide. Ide means amide, ide means amide, anyl means aniline, aceto means two carbons. Acetanilide. So we are using strong reducing agent lithium aluminum hydride. So the secondary amide undergo reduction and it gives corresponding secondary amine. It is a secondary amine, secondary aromatic amine. It is treated with Hinsberg reagent. Hinsberg reagent has leaving group and nitrogen is nucleophile. Therefore, SN2 reaction takes place. N lone pair attack, leaving group will leave. So we get our corresponding secondary sulfonamide. And the secondary sulfonamide is water insoluble, therefore it is a PPT. Now the PPT treated with aqueous NaOH. So here there is no acidic proton. Therefore this PPT is insoluble in aqueous NaOH. So secondary sulfonamide, it is a secondary sulfonamide insoluble in aqueous NaOH. It is a primary alcohol. When primary alcohol treated with potassium dichromate, it is a strong oxidizing agent. Therefore, primary alcohol undergo oxidation and form corresponding carboxylic acid. When carboxylic acid treated with secondary amine, for example, it is a carboxylic acid, it is treated with secondary amine. So initially acid-base reaction takes place and form corresponding salt. Now on heating, it undergo dehydration and form corresponding tertiary amide. So similarly in this case also, if you want to write the answer directly, you can write answer directly like this. So it forms corresponding tertiary amide. Now the tertiary amide treated with strong reducing agent lithium aluminum hydride, the amide group undergo reduction and converted into amine. The amide part undergo reduction, converted into amine. It is a tertiary amine. The reactant has alkyl chloride functional group and alkyl bromide functional group. But here bromine connected to benzene. So we know that when the bromine connected to benzene, it won't affected by nucleophile. but the Cn minus can attack on this carbon, leaving refill through SN2 mechanism. So we know that when alkyl chloride treated with NaCN, we get cyanide and isocyanide. Cyanide will be major through SN2 mechanism. When alkyl chloride treated with AgCN, it forms cyanide and isocyanide. Isocyanide is major through SN1 mechanism. Therefore, the corresponding product is, I am considering major product. So, major product CH2 C triple bond N. Now, this product treated with Grignard reagent pH minus. So, it is a nucleophile as well as base. So, here act as a nucleophile. So, nucleophile do not react with bridge carbon, but nucleophile react with the cyanide. Pi bond will be shifted. So, the basic reaction is when cyanide treated with the Grignard reagent, nucleophilic addition takes place. Now this product after hydrolysis undergo hydrolysis and gives corresponding ketone. So similarly here also, after attacking pH minus and then hydrolysis, it forms finally corresponding ketone. Now the ketone treated with NH4CN. NH4CN means NH3 plus HCN. So whenever the ketone treated with ammonia, it forms corresponding imine, and this imine react with HCN, H plus and Cn minus, nucleophilic addition, we get corresponding NH2CN. So similarly in this case also, first we have to remove the H2O and form corresponding imine. Now the imine functional group undergo nucleophilic addition and form corresponding product like this. So this is our final product. The first reaction is SN2 reaction, second reaction is nucleophilic addition, and third reaction also involving nucleophilic addition. The reactant has aliphatic amine, aromatic amine, and we are using chloroform and KOH, only one equivalent. So here chloroform and KOH produces electrophile CCl2. So the corresponding primary amine react with electrophile. After multiple steps, finally it forms corresponding isocyanide. So amine converted to isocyanide. It is a foul smell compound and also can be used for test for primary amine. And here the reaction starts by donating its lone pair. The reaction starts by donating its lone pair. So strong nucleophile is required, strong base and strong nucleophile. If both are competing, if two nitrogens are competing, we have to look for the strong base or strong nucleophile. So here this lone pair participate in the resonance. Therefore it is a weak nucleophile, and this lone pair is free, it is a strong nucleophile. Of course it is also strong base. Therefore this lone pair will react, and finally the corresponding product is isocyanide. Now this reactant treated with hydrolysis condition. So we know that when RNH2 treated with OH minus and H2O, there is no reaction. But when isocyanide treated with OH minus and H2O without heat, OH minus attack on the carbon, pi bond shifted. Finally, the product is RNH double bond, single bond, C double bond OH. It forms corresponding amide, secondary amide. And the same isocyanide OH minus H2O, heat is given, it undergoes complete hydrolysis and forms corresponding amine and formic acid. So here complete hydrolysis is given, heat is given, complete hydrolysis and form corresponding hydrolysis product. Again we get our initial reactant. Now the product is treated with AC2O. It is simply acetic anhydride. I am using only one equivalent, so it is a leaving group. So this lone pair can attack and this lone pair can attack. So we know that because of the resonance, it is a weak nucleophile, it is a strong nucleophile. Therefore, N acylation takes place and form corresponding secondary amide. So this functional group is secondary amide. The first reaction is carbyl amine reaction. So this reaction is known as carbyl amine reaction. First reaction is carbyl amine reaction. Next one is complete hydrolysis. Next one is acylation. The reactant has two functional group. One is alcohol functional group. One is ether functional group. Alcohol functional group and ether functional group. And we are adding tosyl chloride in the presence of pyridine. So we know that when alcohol treated with tosyl chloride, so lone pair attack on the tosyl group, Cl will leave, and finally we get corresponding ROTS and HCl. And this HCl react with pyridine and forms corresponding pyridinium chloride. So here we are using pyridine to remove the HCl. So therefore here O lone pair attack, Cl will leave and form corresponding above the plane OTS, above the plane OPH. Now it is treated with sodium azide. N3 minus. N3 minus is a strong nucleophile. Therefore look for the SN2 reaction. We know that OTS is good leaving group. Therefore SN2 reaction takes place and Walden inversion observed. So because of the Walden inversion, below the plane nucleophile and remaining group is unaffected. Now it is treated with strong reducing agent LiAlH4. So ether do not react with LiAlH4, but azide will be converted into, this azide group will be converted into primary amine. Therefore this N3 group, azide group, will be converted into amine group. Azide group will be converted into amine group. So this is our final product. The first reaction, retention at the chiral center, retention. Second reaction, inversion. And third reaction, retention. The reactant has carboxylic acid and ammonia. So carboxylic acid treated with ammonia. Initially acid base reaction takes place salt will form. When this salt is heated, undergo dehydration and form corresponding primary amide. Form corresponding primary amide. So here we get our corresponding primary amide. It is our corresponding primary amide. Now this primary amide treated with NaBr and BrO3 minus. So this is equal to Br2 plus OH minus equal to BrO minus equal to Br2 plus CO3 minus 2. So we know that when primary amide treated with Br2 plus OH minus, this reaction is known as Hofmann bromamide reaction. This reaction is known as Hofmann bromamide reaction. So here the CONH2 will be converted to NCO. It is what we call isocyanate. Isocyanate. Now it undergo hydrolysis. Finally we get corresponding amine. So in this case also this amide group will be converted into amine. It is a Hofmann bromamide reaction. Now it is treated with CH3COCl AlCl3. So this is a Friedel-Crafts acylation. Friedel-Crafts acylation. So because of NH2 do not undergo Friedel-Crafts acylation, we know that aniline type of compound form complex with Lewis acid. Form complex with Lewis acid. Form complex with Lewis acid. Therefore, it won't, because of meta-directing group, it won't undergo Friedel-Crafts acylation. But here one more group is there, that is methyl. So with respect to methyl, reaction takes place. With respect to NH2 do not takes place. But with respect to CH3, reaction takes place. Finally, the product is Friedel-Crafts acylated product. It is our electrophile attached with respect to CH3. The first reaction, amide formation. Second reaction, Hofmann bromide. Third reaction, Friedel-Crafts acylation. The reactant has two nitro groups. In the presence of sulfur compound, sometimes they also give NaHS also. So whenever we see the sulfur group, so only one NO2 group undergo reduction. If number of moles not mentioned, excess not mentioned, only one NO2 group will be reduced. NO2 will be reduced to NH2. Now the product is treated with NaNO2HCl. From this we get HNO2 and from this we get NO2, NO plus electrophile. So this NH2 react with NO plus. Finally this reaction is known as diazotization. So because of diazotization reaction, NH2 group will be converted into N2 plus. Now this diazoning compound treated with HBF4. So initially it forms water insoluble salt. When this salt is heated, it loses N2, it loses BF3 and one more F is left, and that F react with the corresponding benzene through ARSN1 mechanism. So it loses N2 gas, it loses BF3 gas. So this entire reaction is known as Balch-Schiemann reaction. This entire reaction is known as Balch-Schiemann reaction. First reaction is reduction of NO2, second reaction is diazotization, third reaction is ARSN1 mechanism. So this BF4 minus compound is water insoluble. The reactant has NO2 group, leaving group. Now it is treated with nucleophile CH3O minus. So here if you observe the reactant, so it is having leaving group, para position minus R, and you are adding nucleophile. Therefore it is a ARSN2 mechanism or SNR mechanism. So here what happens? Nucleophile attack at this carbon. So C minus will form here, C minus will form here, C minus will form here in mechanism. So this minus will be stabilized by minus R. Therefore here we have to remove the Cl and write down corresponding nucleophile. So here even though bromine is good leaving group, it is not replaced, because if CH3O minus attack here, we get negative charge here, we get negative charge here, we get negative charge here, and the negative charge is not stabilizing by minus R. That's why we are replacing only chlorine. Now it is treated with magnesium metal, and here we are having alkyl halide. Therefore the corresponding product is Grignard reagent, C minus, MgBr plus and nitro group. Now this compound is treated with acetyl acetone. It is a acetyl group, it is a acetone group. Acetyl acetone. Now it is an active methylene. Because of active methylene, it is more acidic than water. It is more acidic than water, simply act as acid. So whenever we are using Grignard reagent, first we should look for the acid base reaction. So it is more acidic than water, therefore C minus, remove the proton from the active methylene and form corresponding product like this. The C minus takes the proton and the remaining intermediate is corresponding carbon ion. After removal of proton, it forms corresponding carbon ion. So be careful about the Grignard reagent. Whenever you see the Grignard reagent, first always look for the acid base reaction.